So we are going to practice a past paper question from the motion graph. The syllabus content is that of AS Physics. This is your question number 1. Okay, so but this is a big question. So this question, it moves across 3 screens. I'll also be simultaneously showing you the mark scheme as we solve this question. So going through the mark scheme, as I always say, is very important because it gives you an idea what Cambridge for CIE expects you to write in your answer. And if you are liking the video on this channel, please do subscribe because it is greatly encouraging, and do not forget to like the videos as well. So let us understand what is happening. A stone is thrown vertically upward. The variation with the time t of the displacement s of the stone is shown in this figure. So in this figure we are talking about what kind of a graph? We are talking about a displacement time graph. You have displacement and time. So let us look at the question. Use this figure to describe without calculation the speed of the stone from time t is equal to 0 to time t is equal to 3. They are asking you to describe how the speed changes during this time interval starting from 0 to 3. So first let us understand what is happening here. A stone is thrown vertically upward and the variation with the time t of the displacement of the stone is shown in this picture. Let us draw a picture of it. Let us draw a stone. Let us take a small piece of stone. It is thrown vertically upward. So what happens when an object is thrown upward? It moves up. The object moves up, and after some time it turns back and comes back. So this is what is happening. You're taking a stone, you're throwing it up, it goes up and it starts coming down. This is precisely what is shown in the graph. The displacement is increasing. If you see, you have displacement on the y-axis. As the time is moving on and on and on, the displacement is increasing from the point of origin, from the starting point. Where is your starting point? This is your starting point. So from this starting point, if you see, the displacement is going up. This distance is increasing. Slowly and steadily, you reach the topmost point, which is simultaneous to this point. You reach the topmost point and then the displacement is coming down. The y-axis values, if you trace the graph as I'm showing with my pointer, the y-axis values are coming down because you're coming down on the y-axis. Y-axis values are going down if you trace the values as I'm showing on the screen with my pointer. Y-axis value is going down, which means the displacement is going down. So the ball is coming back, displacement is going down. Displacement means this distance from this starting point, it is decreasing. Displacement is decreasing. It reaches the same starting point. Displacement is 0. Where is this point? The point where the ball is right now, displacement 0. That means you have come back to your original position. You are at this point. Ideally the ball would go up something like this. The ball would go up and it would fall down. It will take the same path. It will come back. It will trace back the same path. But if we are talking about tracing back, you will not be able to look at what is happening in the path between. So I'm just splitting the going up path and the going down path by a slight angle in between. Right? These two lines are drawn as separate. But ideally it will go up and come back in the same straight line. So if it goes up and comes back in the same straight line, when it comes to the starting point, the displacement is 0, which corresponds to this point. Displacement is 0. This is the time, this particular value of the time is the time when the ball has come back. The displacement, the y value is 0. This is the point. What happens after this point? After this point also, if you see, displacement is happening. But a negative displacement is happening. If you see, the positive values are up above, the negative values are down below this x-axis. So displacement is still happening, but a negative displacement. So can you understand from the picture how this displacement is happening? This ball is going down, further down. Let me use the red ink to show the negative displacement. It is going further down. So maybe the ball was thrown from a point which was above the ground. Maybe you were holding the ball in your hand and throwing it up, and when it came back it reached the ground. Or maybe you were standing on a building when the ball was thrown up, and when it came back it is coming back to the original position and then falling down the building. So this is what is happening. We have understood the motion of the ball from this graph, right? We have understood what this displacement time graph is telling us. The ball goes up in the air, turns, comes back to the original place from where it was thrown, and then falls further down. Displacement is happening in the negative direction. Why? Because above this point of origin, displacement was all positive. Below this point of origin, all the displacement would be negative. Negative sign. Displacement is a vector which has a direction. So we are taking all the upward displacement as positive and the downward displacement as negative. So this is what is happening. So use this figure to describe without calculation the speed of the stone from time t is equal to 0 to time t is equal to 3. So this is the moment which is same as time t is equal to 0, and this is the position at time t is equal to 3 seconds. Alright. So what is happening when you look at, visualize at the pattern of the movement of the stone, you can immediately write your answer that initially it is moving against the gravity, so it is decelerating in this portion, first portion of the graph. It is decelerating here, and while it is coming down all the way, it is accelerating. So initially decreasing speed, it reaches 0 speed, turns back, and it is accelerating. This should be your answer. So I've said the answer, you can write it with the pens, the same thing. Let's see what the mark scheme says. The speed decreases or the stone decelerates to rest or 0. Precisely at what time, that also will identify from the graph. And then the speed increases or the stone accelerates in the opposite direction. So it's a 2-mark question. If you are talking about deceleration, you get 1 mark, acceleration 1 mark. So let us come back to the question. At what time is the stone taking a turn? At the topmost point. At the topmost point, the stone is taking a turn. What is the time value at this point of time? Time value, if you read the graph, it will come out to be 1.25. The time value at this moment is 1.25. So at time t is equal to 1.25 seconds, it is at the topmost point when you have the maximum displacement. Topmost point. Time t is equal to 1.25 seconds. Alright, so we have understood these things. Let us move on and solve the other parts of the question. Now the next part of the question says, I have taken the graph again on this slide as well, because it's a continuation of the question and we'll be using the same graph to follow the next set of questions. And I have also taken a note of the 4 4 equations of motion, right? These are your 4 equations of motion that you should be aware of. Alright, so B part. Assume that air resistance is negligible, therefore the stone has constant acceleration. Calculate for the stone the speed at time 3 seconds. So which one of these equations do you think makes sense here? Which makes sense to calculate the speed at this point? I think the first equation makes sense. Why? Why? If we are considering only this part of the graph, only this part of the motion, which corresponds to the movement from this point to this point in the graph. Alright. So what is the initial velocity? What is the initial velocity at this point? Initial velocity is 0. Why? Because when you are at this point, at the topmost point, the velocity is 0 meters per second. And what is the time taken? What is the time taken to reach this point, starting from this point? The time taken is 3 minus 1.25, which would be 1.75 seconds. So the time from this point, at the topmost point to the bottommost point here is this much. You know the value of the time t as well. You know the acceleration. Everything is happening under the influence of gravity. The stone is moving up and down because there is no air resistance. The acceleration is your g, which is 9.81 meters per second square. So let us use the equation. V is equal to u plus at, which would turn out to be 0 plus 9.81 times the value of the time, 1.75. This will give you the value of the speed. Let us tally the answer as well with the mark scheme. Let us see what they have done. Yes, they have used the same equation. Time value is also the same. Everything same. So you should get your answer, which is 17.2. 17.2 meters per second. This should be your answer here. Alright, so this part is done. Now the next part of the question, the distance travelled from t is equal to 0 from this point of time to this point. From time t is equal to 0 till the last point, which is 3 seconds. So the whole distance that is travelled, so you have to add up all the way, the distance going up, all the way coming back to the initial position, and all the way going down. How do you find this? Let us use some of the equations where you are given S. So equation 3, if you see, equation 3 looks kind of a good equation to use if you are calculating the distance when you are going up. So when you are going up, how much is the distance? If you are using this equation number 3, if you are using, listen carefully, if you are using equation number 3 to calculate the distance when you are going up, this distance, do you know the initial velocity? Initial velocity means velocity at time 2 is equal to 0, at which the stone was given a push up. Do you know that velocity? You do not know that velocity. Similarly, for equation number 2, you have u in this equation. You do not know the initial velocity, though you know the final velocity at the topmost point, which is 0, but the initial velocity you do not know. So none of these equation 2 or 3 can be used to calculate the distance in the first part of the movement of the stone when it is going up, all the way up in the sky, right? But we know that this distance is equal to the distance here. They are same. They are the same, right? The distance traveled up is same as distance coming back until it reaches the original point. They both are the same. Can we apply the third equation? Can we apply the third equation to calculate the distance in this part of the graph? You can also apply the second equation to calculate the distance when you are applying this equation when the ball is moving down. You can also apply 2 or 3, both are applicable. Let us work with equation number 3. You can in your free time work with equation number 2. So when we use equation number 3 for this part of the graph, which I am showing with my pointer, what is the initial velocity? It is 0, because initially at the topmost point the speed when the object takes a turn is always 0. And final velocity you do not know. You do not even need that time, it's not required. But do you know the acceleration? Do you know the acceleration? Acceleration is g, which is 9.81. Do you know the value of time? The time taken to reach from the topmost point to this point. So this you can find out from the graph. Time taken to reach from the topmost point to the bottommost point. I'm sorry, let me make a straight line. The line got slightly bent. This is the time they are talking about. So you can calculate it. Here the time value, if you read the graph carefully, you'll find out it is 2.5. At this location it is 1.25. So you can subtract these two numbers. Time t would be 2.5 minus 1.25, which is 1.25 seconds. You can input the values in this equation. So S will be, ut is 0 because u is 0. So half g, which is 9.81 times the time, 1.25. This gives you this distance. This will give you this distance. Starting from the topmost point till here, it will give you this distance. Alright, which is same as the distance here. So you have calculated, you have in a way calculated this part. You have calculated this. You have calculated this. Now you have to add the displacement or the distance when it is coming down all the way to the bottommost point. Starting from the top all the way to the bottommost point. For that case as well, u is equal to 0, g is equal to 9.81. Time in this case, we are not talking about this whole distance. D dash, let's call it D dash. We are not talking about D dash. So time taken to travel the distance D dash will be 3 minus 1.25. So 3 minus 1.25, so which is 1.75. Input the values. Say that you had calculated S1 earlier, now S2. So u is 0, half times 9.81 times 1.75. Do your calculations, you'll get the answer here, you'll get the answer here. So what is the total distance traveled? It will be your S1 plus S2. But what is S1? This is D is your S1. D dash is your S2. You have calculated S1 all the way, distance going up, which is same as the distance coming down. So you had calculated the distance coming down from the topmost position to the original position. This is what you calculated, which is D or S1, together with S2, which is the distance from the topmost point to the bottommost point. calculate them, and you'll get your answer. If you are using equation number 2, you can do that as well. You can get the solution if you are using equation number 2 as well in the mark scheme, because the mark scheme talks about 3 ways. And one mistake, this is t square, right? Half a t square, so these numbers are squared here. The equation says t square. It's my mistake, I'm correcting it now. Alright, so let us come to the mark scheme. So this is precisely what I have explained here. Some other ways of doing this is a second way of doing this question. This is the third way of doing this question. If you are using other equations of motions, you can solve this whole question in 3 ways. We have done in the first way. Fine. Let us come back to the screen. So this question is done. It was slightly complicated, hence it is a 3-mark question. Alright, go through it, listen to the theory which I've just explained again and again. It should make sense. And still, if you have any question, please ask your questions in the comment box. I'll clarify it. Now the next question is, the displacement from time t is equal to 0 to time t is equal to time t is equal to 3 seconds. So total displacement starting from the original to the final point. How do you find the total displacement? If you come back to the original screen, distance is different from distance, because distance is the total length that you have traveled, whereas displacement is how much? Only this much. Only this red line is the displacement, because it tells you how much you have displaced from your original position. So from your original position, you have only displaced by the length of this red line. And what should be the length of red line? It should be S2 minus S1, because S1 is same as this blue line. Right? So S2 minus S1. So whatever S2 you have calculated here, subtract it from S1, it will give you the displacement. S2 minus S1. You'll get your values, you'll have to use a calculator. This is your S2 and S1. And what is the direction? What is the direction? Look at the picture again. What is the direction of the displacement? It is downwards. So let us tally with the answers. You subtract both the numbers and the displacement is downwards. Make sense? Let us come to the last part. Draw the variation with the time t of the velocity v of the graph starting from time t is equal to 0 to time t is equal to 3 seconds. So you have to convert this displacement time graph into velocity time graph. How do we do that? Let us look at the scenario. So when you are giving a push to the stone, when the stone was in your hand, this is the first screen, first question where we had drawn the complete diagram. So I am coming to the first screen. So when the stone was in your hand, you gave it a push, right? You gave it a push, you threw it up, it went up, reached a 0 speed at the topmost point, and then it started gaining speed. So initially it had a very high speed, it was pushed up at high speed, decelerated to 0, and from 0 it accelerated to a higher speed as it was going down. So how much was the speed initially? It is not given to you. So let us assume it had some positive speed initially. It had some speed. That's why the numbers are not given here. You need not mention the number. Say that it started with any positive velocity. Okay, let us come back to the same scenario. What was the velocity? What was the velocity when the ball started from this position and reached the topmost position? The velocity at the topmost position was, the velocity was 0, because it was taking a turn. Whenever an object reaches the topmost point, always do remember The velocity at the topmost point is always 0. When the ball reaches the topmost point, the velocity is 0. That's a property of throwing the object and it reaching the highest point. At the highest point, always the velocity is 0 meters per second. So at what time is this happening? At time t is equal to 1.25. So this is a very critical time, 1.25. Make a note of it in your graph. So where is 1.25? It is at this point. So the velocity is decreasing all the way in this region. If you look at the graph also, the velocity is decreasing from time t is equal to 0 to 1.25. It is decreasing, and after 1.25 it is increasing again, but in opposite direction. The direction has changed. Earlier the direction was upward, now the direction is downward. The direction has changed. It is increasing in upward direction, but with the same acceleration of gravity. So the velocity will keep increasing, but in the opposite direction. Keep extending it. That's it. That's your graph. This completes the picture. The velocity keeps increasing starting from this point t is equal to 1.25. When the velocity was 0, it will keep increasing and increasing and increasing at the same rate, constant acceleration of gravity. So therefore it is a straight line because acceleration is constant. Right? Acceleration is constant, so it will be a straight line. It will keep increasing and increasing. So let me draw this again because there was a tiny error here. So let me show you how this whole thing would look like. Let me erase this whole thing because I drew it in two parts. So therefore there was a slight bend, because in real life there should be no bend. This is a point which is 1.25. So your graph will start from a higher point. It will pass through 1.25 as a straight line, single straight line, like this. No bending whatsoever at any place. Initially, what is happening? The velocity is going down. It reaches the topmost point at 1.25 seconds, reaches the topmost point when the velocity becomes 0, and then it increases. Can you see? The velocity is increasing again at a constant acceleration. It is increasing in the opposite direction. The velocity initially decreasing, then increasing in the opposite with a negative sign in the opposite direction. So this was your question number 1. Slightly technical, needs a lot of practice. Go through the answers, the explanation again to understand, because it is very well explained in this video. Watch the video multiple number of times if it is not making sense in watching it just only one time.